Okay, this video is going to walk through one of the Chapter 4 homework questions, and it assumes that you have already watched the how to solve any time valued money, or the solution process for solving any time valued money problem. This is going to be an example of how to apply that, and you'll definitely want to go back and watch that video first, because I'm going to assume that you're walking into this one with some knowledge, and it may be a little confusing if you don't have it. So if you haven't watched that one yet, hit pause right now, go ahead back into Canvas and find that how to solve any time value money problem video, and watch that one and then come back to this one. Okay, with that out of the way, let's talk about number 5 from the Chapter 4 homework. Or at least it's number 5 while I'm recording this video. You might be watching the video years later and we have different homework problems. But for spring of 2019 semester, this is number 5 from the Chapter 4 homework. And now the setup for that problem says you have a loan outstanding. It requires making 9 annual payments of $10,000 each at the end of the next 9 years. Your bank has offered to restructure the loan so that instead of making 9 payments as originally agreed, you'll make only 1 final payment in 9 years. If the interest rate on the loan is 11%, what final payment will the bank require, or what final payment will the bank require you to make so that it is indifferent between the 2 forms of payment? Okay, now if you watched the other video, we're going to apply a 3-step solution process. We're going to draw the timeline. We're going to identify the type of cash flow that we have. And then we're going to see what variables we have and which one we're solving for, and then apply the correct formula or the correct solution process that's available to us. All right, so we're going to start with the timeline. All right, and the timeline for this one is going to be 9 years long. I'm going to write 0, 1, 2, and then I'm going to do a little squiggly on my timeline and just go on out to 9 and put ... between 2 and 9 just to say that this pattern repeats throughout there. So I don't have to draw 9 of these. Okay, now let's see what cash flows we are looking at here. It says our original loan requires us to make 9 annual payments of $10,000 each at the end of the next 9 years. So 1 year from today, we would make the additional $10,000 payment. 2 years from today, we would make another $10,000 payment. And then 9 years from today, we would make the final $10,000 payment. It also tells us that the interest rate on the loan is 11%. So off to the side here, I'm just going to write R equals 11%. So I make sure I'm aware of that value. All right, so here's where I want to hit pause. I've got everything on there that the problem gives me. So what I want to do now is look at the cash flows and figure out what type of cash flow I'm dealing with so that I know what solution process I can use. Okay, and what I've got here is level payments of $10,000, right? It's a repeating $10,000 payment at regular intervals. It's at the end of each of the next 9 years, and then it stops after year 9. Now, the definition of that type of cash flow is an ordinary annuity. The payments are happening at the end of the period, they are level, they're at regular intervals, and they stop. So that is an ordinary annuity. And if we look back at those notes or think back to that video of how to solve the time value money problems, if we've got an ordinary annuity, we have 2 solutions available to us, or 2 solution processes available to us. I can use either the formula or I could use the calculator because I've got an annuity, and we'll walk through both here. Let's say I'm going to use the formula first. If I know I'm dealing with an ordinary annuity, I can look to the formula sheet and go to the Chapter 4 formulas, find the 2 that have ordinary annuity in the title. Okay, here we go. We've got the present value of an ordinary annuity and the future value of an ordinary annuity. And those are the only 2 formulas that I can use for this type of cash flow. So now I've got to figure out which one of those I need. Okay, and if I look back to the problem, I'll see that it says your bank has offered to restructure the loan so that instead of making 9 payments as originally agreed, you will make only 1 payment in 9 years. All right, so that means at the end of 9 years, I'm going to make some payment here at the end of the timeline instead of making 9 payments of $10,000, such that the bank is indifferent between the 2. All right, so what that's asking for is here at the end of the timeline. So what it's asking for is what is the future value of the stream of payments, right? The bank's going to be indifferent between me making 9 payments or just giving them 1 lump sum at the end. Then the values of those 2 cash flows must be exactly the same if the bank is indifferent between them. So what I need is the future value of the stream of $10,000 payments. If it were asking me, what I borrowed today at time period 0, or what would the value of it be today, then we'd be looking for present value. In this case, we are looking for future value. Okay, I'm going to use this simplest form of the future value equation. So that's the cash flow divided by R times the quantity of 1 plus R raised to the n minus 1. All right, so I'm looking for the future value of this annuity. I'm going to put subscript 9 on it just to know, so it's a note to myself to know when I'm looking for this future value as of. All right, and that is going to be C over R times the quantity 1 plus R raised to the n minus 1. All right, let's fill in those variables. The future value at time period 9 is 10,000 divided by my interest rate, 11%, times the quantity 1 plus R. Again, my interest rate is 11%, so I'm going to go ahead and write those together as 1.11. That is 1 plus 0.11. Raised to the n, that is the number of periods, or the number of payments in the annuity, which is 9 in this case, minus 1. All right, so my future value at the end of year 9 for this annuity is, let's plug this in. Okay, we're starting out with 10,000 divided by 0.11 equals 90,909.09. All right, and I'm going to use the memory function on my calculator, and I'm going to store that value on the number 1 key. And if you're using the BA2+, the way you do that is hit the STO key, that's just to the left of the number 4, and then choose a number key to store the value on. I'm going to choose to store it on 1. All right, so with that value on the screen, I hit STO for store and press the 1 key. And what that did for me was store a 13 decimal version of this number on the number 1 key for me. All right, now I have my calculator set to 4 decimal places, so it's only showing me 4, but your calculator works out everything internally to 13 decimal places. And when I store that value so I can recall it later, I can use the 13 decimal version of that, which will eliminate some rounding errors for me. And that's the reason I'm using it. Okay, now let's work what's inside the brackets. That is 1.11 y to the x 9 minus 1 equals, right? So that's 1.558. And I'm going to store that on the number 2 key by hitting STO2. And now I have stored that 13 decimal version instead of the 4 decimal version. Okay, so to multiply these two numbers together, I'm going to use the stored values so that I don't introduce any rounding errors. I'm going to say recall 1 times recall 2 equals 141,639.72. All right, and $141,639.72 is the future value of these 10 payments. So if I were to put that on the timeline here, that would be an end of year $9. So that's $141,639.72 end of year $9. Okay, so the bank in this case is indifferent between me making 9 payments of $10,000 or simply giving them one payment of $141,639.72 at the end of 9 years. In either case, they have earned 11% on their original loan to me, and that's what they wanted to do. They wanted to earn 11% over 9 years. Either one of these two forms of payment will give them that. Okay, let's talk about the financial calculator solution now, because this is an ordinary annuity, so we can use the calculator. All right, the way I like to use the calculator is to, in my notes, I'll write it down just as if I were working a regular problem. But in this case, I'm not writing formulas with values. I'm writing down the keys on the calculator. I'm going to write down what I enter on them. Okay, N on the time value money keys, this third row on your calculator, that's N, I over Y, PV, PMT, and FV. N is the number of periods or the number of payments in an annuity. For this problem, that's 9. I over Y is the effective interest rate per period, where the period is defined by what you entered on N. So in this case, we've got 9, and that's 9 years. So for I over Y, I need to enter the effective annual interest rate, and that is 11 in this problem, 11%. Now this I over Y key is expecting a percentage, so instead of entering 0.11, you actually enter 11 for 11%, and the calculator knows that that means 11%. Okay, present value. For this problem, we're actually going to enter a 0 for present value, and that does not mean that the present value of this annuity is 0. The present value of this annuity is the amount that I borrowed up front. It's not 0, but for the time value of money keys, the present value in this case, because I'm going to be solving for future value, the present value, what I put on the present value key is what cash flow occurs at time period 0. And in this case, that's nothing. I'm not making any payment at time period 0. That's when I received the loan. Okay, so we're going to enter 0 for present value. Again, that doesn't mean the present value is 0. It just means there was no cash flow at time period 0. All right, for PMT, that's payment. What was the payment that happened each year? In this case, that's $10,000. And for future value, that is what I'm looking for. Okay, so to enter these on the calculator, first things first, we want to clear the time value of money keys because they are a memory function, and the last problem you worked is still in there. So to clear the time value money keys, you're going to hit second, clear TVM, which is right above the FV key. Second, clear TVM. We'll zero everything out. All right, now I'm going to go left to right and enter them in order. I want to store the number 9 on the N key, and the way you do that is to press the number 9 first, and then press the N key to store it. And you'll see N equals 9 with 4 decimal places after it and a sideways triangle. The equals, the decimal places, and the triangle all tell me that that is now a stored value on the N key. All right, I want to enter 11 for I over Y, so I'm going to type in the number 11 first, and then press the I over Y key to store it. Okay, and again, I see my equals, my decimal places, and sideways triangle. I know it's stored. All right, I want to record 0 as PV, so I'm going to type 0 and press the PV key to store it. All right, I need to enter 10,000 for payment, so I'm going to type in 10,000 and press the payment key to store it for payment. And then I'm looking for future value, so I'm going to hit compute, which is the CPT key on the very top left of the calculator. I'm going to hit compute FV for future value. So compute FV for present value. Okay, and now I see a number with an asterisk. That means it's a calculated value, and it is indeed the same 141,639.72 that we found with the formula earlier. Same number. Now the difference here is there's a negative in front of it. And let's talk about that negative for a second. When we're using the time value of money keys, positives and negatives keep track of the direction of the cash flow. Right? It is not saying that it's worth a negative $141,000. It just means from the way I enter the cash flows, we're looking at a cash outflow of $141,000 at the end of this period. Right? Now, what the heck does that mean? It means the calculator is using a perspective. The way I've entered these cash flows, I am looking at the value of, or what's going to happen if instead of making 9 payments of $10,000, I instead make one final payment of $141,000. Right? So if I make that choice, if I decide to make one final payment at the end of this thing, that means I get to keep 9 payments of $10,000, and those payments, compared to what I was going to do, I was going to make those $10,000 payments. They're going to be cash outflows, but now I get to keep them so they look like cash inflows. I have $10,000 in my pocket at the end of every year that I otherwise would not have had. But in order to get that, what I have to do is have a cash outflow of $141,639.72 at the end of year 9. Okay? So again, it's just that positive and negative is keeping track of the direction of the cash flow. It is not making a statement on the actual value. Only the number itself is related to the value. All right, and that's it for that problem. This process you can apply to any time value of money problem. You'll identify the type of cash flow after you've mapped it out, and then you can know if you have to use a formula and what formula to use, and also if you can use the calculator. If it's a lump sum or annuity, you can use the calculator. All right.